The Airbus A320 has a so-called full authority digital engine control, and it is responsible to ensure that the engines will perform at maximum efficiency for the given condition. It controls and limits thrust to not exceed the limit set via the thrust lever position in both manual and automatic modes. The thrust levers can only be moved manually and are not moved by an auto throttle system. Let's look at the different positions or detents that can be found for the thrust lever. The zero position is considered as the idle position. In this position the engines give around 20% of power. With this power on flat ground the airplane will go forward if no brakes are applied. The climb position of the thrust levers is the most used detent. In flight, this position is set and the auto thrust is usually on to give a speed value for the airplane. Next, let's look at the flex maximum continuous thrust detent. When the actual takeoff weight is lower than the permissible one, the flight crew uses flex takeoff thrust. Flex takeoff settings use an assumed temperature thrust reduction to preserve engine wear and thereby prolong engine life. The engines will be cheated to think that the outside temperature is, for example, 50 degrees Celsius by inserting it to the flight computer. For higher temperatures, the level of thrust decreases as a function of outside air temperature. Takeoff go-around thrust is not always 100%, because takeoff go-around thrust is actually not about delivering the absolute maximum thrust that can be provided. Rather, it's about delivering a guaranteed large amount of thrust, to ensure the performance of the aircraft is what the pilot expects, and what the flight manual states will occur. The level of thrust needs to be predictable. Thrust reverse is idle position. Reverse thrust is a function that opens hatches on the side of the engines to divert the engine thrust forward, providing deceleration of the airplane. Thrust reverses idle position is a power lever position where the thrust reverses are deployed but the engine RPM remains idle. When the thrust levers are set full aft and reverse thrust is applied, the thrust reverses hatches are open from the side of the engines and a thrust of around 61% is produced by the engines to apply effective deceleration for the aircraft.